1.1, Geometry Essentials. We're going to jump right into talking about points, lines, line segments, endpoints. You've dealt with stuff like that before, I think. Yes? You're at least familiar with those terms. A point occupies space, but occupies no volume or space, okay? So a point is just there. It has no volume or space to it. A line is defined by 2 points, and it passes through. In geometry, it's important that you know symbols. Symbols are just as important as knowing the vocab words. So when you see something written like this, AB under something that looks like a line, that means you have line AB. Another way for it to be written is with a lowercase l. It will either be in cursive or it will almost look like an I sometimes because they make that funky looking one, you know what I'm talking about? Okay. So a line is defined by 2 points, it passes through. A line segment is part of a line, and it is written as follows. This is segment AB. So the line up here above the AB does not have arrows. If you write this for this, it's wrong. Okay? An endpoint is an end of a segment or array. There's endpoints of rays. There's also starting points of rays. Array is a portion of a line that starts at a point and extends forever. Here's how it's written in like code ways. This says ray, CA, okay? So I just write it with nothing on this side and an arrow pointing this way. Even if it's opposite direction for you, you still just write it this way when you're writing it in terminology forms. Does that make sense? Okay. A plane is a 2-dimensional figure. It continues forever in 2 dimensions, and it can be defined by listing any 3 points on it in which they are not in a line. So 2 of the points could be in a line, but the third one has to be outside of that line. Otherwise, I've just listed a line. I haven't listed a plane. Do you comprehend that? We'll go over it on these pretty pictures over here in a minute. And then the last term we're going to talk about today is a postulate. And a postulate is a statement that is accepted to be true without proof. So when it says this is a postulate, you're like, okay, that's true, and I'm not questioning it. Right? Okay. And it's used to help prove other statements that we have to do later on with proofs, and you're going to love those when we get to chapter 3. Now, in the red, there are some points, lines, and plane postulates that are written out. Okay? You'll have time to write to a little bit later, so if you need to listen first, you can do that and then write later. Or you can take pictures on your phone at the end of my lesson too and have them that way. Okay? So here we have 2, 4, 6, 7 different postulates we're going to talk about today. One is a line contains at least 2 points. So for something to be a line, there has to be 2 visible points on it. Okay? Exactly 1 line passes through any 2 points. So I can only have 1 line pass through 2 points. Exactly 1. If 2 lines intersect, they intersect at exactly 1 point. So here I have 2 lines intersecting. They intersect at exactly point G. 1 point. Okay? A plane contains at least 3 points that are not on a line, which is the same as what we basically said over here with how we define a plane. So they're kind of the same definition there. Exactly 1 plane passes through any 3 points, which are not on a single line. If 2 planes intersect, their intersection is a line. So if I have 2 planes that cross each other, they're going to cross and form a line. We'll talk about that too. And if 2 points are in a plane, then the line containing those points also are in that plane. Okay. Let's look at these pictures and we're going to talk about some. This here is a plane. Okay, that's how we're going to symbolize it. Because planes are hard to draw. We don't really see them necessarily, right? A sheet of paper is a plane. So this right here is a plane. Okay? Now, on this plane, I have points all over. You just don't visibly see them. I can view this. Let's go like this. I can do this, and I can stick this marker through here that's going to represent a line, and I have a line passing through a plane. I have a line passing through a plane where? Where does it pass through a plane? Right there in the middle. What is that going to be represented by? What does a line in a plane when they intersect create? Exactly. What? Go for it. Exactly 1 point. So where this plane is, and this line crosses through, there is a point right there. Okay? Now, if I have, let's do this. If I have two planes, okay, if I have two planes and they intersect like this, my planes are intersecting, pretend that they're cooperative planes. What do they create? A line, okay? This right here is a line that they create. You see that, okay? And a line is defined by what? 2 points. So there has to be 2 points right here somewhere, okay? Whether that's here and here, or in this middle where they intersect, there's a point, okay? Whatever happens, that line has 2 points on it, okay? So I've got planes and stuff happening. Does that help you a little? See that? Okay. So when we draw it, we just draw a plane kind of like diagonal so that we can say that that's a plane, okay? So here I have a plane. If I want to name this plane, how can I name that plane? You have to have how many points to name that plane? Nope. 3. You have to have 3 points that are not on a line. So how could I name this plane? There's lots of ways I can name it, but how could I name it? What?
Write letters?
Yeah, write letters. What letters? Okay, so I could name it plane A, B, C, D. I could name it plane, I can start here, D, A, B, C. I can name it plane D, C, B. I don't have to put all 4 in. Do you get what I'm saying? Okay, so there's several ways that you guys will write your answers depending on how you think. And there are several answers that you can have in geometry that are correct. So just because your neighbor has a different answer than you doesn't mean that you're necessarily wrong. You might be, but you might not be. Because there's a lot of ways I can write the same thing. Does that make sense? And I think in algebra we're used to being like, here's the answer. But in geometry we have to think outside of that box because there are several answers that could encompass and help us, okay? Here I have 2 lines. When 2 lines intersect, they create a point G, okay? So I have line in. Do you see how these have an N and an M right there? They're kind of like a cursive one. They'll name lines like that. They'll say line N or line M. But I could also name this line here line DG, okay? And I could write it. How would I write that? What do I have to put over there? Yes, one with arrows both ways. So this is line DG, but it's also line N. Okay, do you see how we can get confused maybe? Okay, so there's lots of ways I can do that. Here, I have a line, okay? I have line X, Y, or line K, but I also have a line segment. What is my line segment there? X and Y. So when I write that, I have to write it with a bar over top, no arrows. I also have here a ray. I actually have 2 rays. What are my 2 rays that I have? What? Y and well, K is the name of the overall line. It's not on there. So if I want to write a ray, I can write it one of 2 ways. I can say ray YX like this, which means I start at this point and continue on forever this way. Or I can say ray XY, which means I start here and continue on forever that way. So you have one ray that goes to the right and one ray that goes down to the left. Does that make sense? Okay. So I have lots of things that I can do there. So here's another diagram. I'm going to throw some questions out and you're going to throw some answers my way. How's that sound? Okay. So here's some questions I have for you. What is this? Let's go this way. I'm going to use blue so that it's kind of in here. Question A. What is like, is it a ray, a point, a line? Oh, it's a what, right? Oh, yes, Carly. It is a line segment. Good. Okay, let's go with this. What is that? A line. A line. Don't be afraid to answer. What is that? What is A? What would that be if I just said A? It's a what? A point. It's a point. Okay. And how about this? What is that? A ray. Okay. So you're going to have to be able to identify those things. You're going to have to be able to draw those things. Cool? Okay. The next part that we're going to have to be able to draw and identify are angles. You guys have done angles before. I know you've done them in pre-algebra. You probably did them in algebra some too. Okay? So just our standard angles. An angle is formed by two rays with the same end point. So here's A ray with the endpoint B. Here's A ray with the endpoint B. Okay? So an angle's definition is that it's two rays with the same endpoint. I can write this several different ways. I can name it angle B. Okay? So this is the symbols. This is the verbiage. Okay? Or you can name it angle ABC. Or you can name it angle CBA. So when I ask you on a test, name this angle, you can name it one of three ways. And everybody next to you might have a different answer. That's fine. Okay? The key point is this. You either name it with its end point, or you name it with its end point in the center of the other two. You get what I'm saying? It's like a little sandwich. Okay? A little B sandwich there. And that's how I can name that. Okay. We have four types of angles that we're going to focus on for right now. An acute angle is less than 90 degrees but greater than 0. Okay? So, example, this is a 38 degree angle. It's not really a 38 degree angle. I just wrote it in there like that. So in your book, when you're using your protractors to read things, remember that sometimes the book image isn't going to be equal to your protractor, so go by what it labels it. Just go by what it tells you it is. Know that as a statement, a true fact. An obtuse angle is greater than 90 degrees but less than 180, so it's going to have a large mouth, 126 degrees. A straight angle is 180 degrees, so this would be called a straight angle or a line. We can name it either. Okay. And a right angle, of course, is equal to 90 degrees, and it will always be symbolized by that box, that 90 degrees. Okay. Those are things you probably are familiar with. Yes? Okay. Last thing we're going to talk about is something called the angle addition postulate. Okay. When I have, like here it says, if S lies within angle PQR, so S is within this ray here lies within my overall angle, then I can have an angle addition postulate, which is going to come and play a lot this year. Okay. What it's saying is this angle PQR equals this smaller angle of PQS plus the angle of SQR. Okay? Think about that. If I have the whole, the two pieces add together to give me the whole. Yeah? Does that make sense? Okay? So that is what the angle addition postulate says. Now here's the deal. You could have an angle that's obtuse and you could have 6 angles within it. all 6 of those angles add up to be the whole. It's like fractions, okay? It's like when we deal with fraction math. So here I just have 2 halves. So angle PQS plus the measure of angle SQR equals the measure of angle PQR. So if this whole angle here, okay, let's say this whole thing, that represents the whole angle, is measured at, I don't know, 38 degrees, okay? Then that means that the measure of this small angle here plus the measure of this angle here has to equal that 38 degrees, okay? So that's what this M stands for. It stands for measure. Okay, so when you see that in front of an angle, we're talking measurements. Does that make sense? Okay. So let's say that this one here is, I'm just going to make up a number, 22 degrees. Okay. So that means I would say the measure of angle PQS plus the measure of angle SQR equals the measure of angle PQR. I would then substitute numbers in that I can. So 22 degrees is this angle. So 22 degrees plus the measure of angle SQR equals 38 degrees. Now can I solve for what this measure is? How? What do? Go for it. Just shout it out. Yeah, I'm going to take 22 and subtract it from both sides, right? And so I get the measure of angle SQR equals 876 degrees, yes? So we're going to start solving things that way. Now this right here, what we just did, is a proof. I just didn't write the answers next to it, which in proofs we're going to write the reason we can do things next to it. So we're starting to get a little taste of what things look like. Okay. Drawing segments and angles. We're actually going to save that for Monday because I didn't tell you to bring your protractors and compasses, but you need to bring those from now on. Okay? Cool? So that's where we're going to stop today. I'll give you a little bit of homework and we'll see how it goes. How's that? Cool. Yep, you can take a picture and then put your phone back in.